in this lecture you find out the area of the shaded region. In the drawing we have those two semicircles. This is line segment AM, is equals to 3 units in its length. This is line segment MN, is also equals to 4 units in its length. This is line segment NB, is equals to 2 units in its length. Again, our task actually is find out the value of this shaded region, or in other words, we have to find out the area of this small semicircle. Okay, so first of all, what is the length of this AB? AB is the diameter of this big semicircle. AB in total equals to AM, that is 3, plus MN, that is also 3, MN is 3, plus NB, that is 2. So in total, AB equals to 3 plus 3 plus 2, that is 8. So now, the diameter AB of the big semicircle equals to 8. AB equals to 3 plus 3 plus 2, that is 8. The diameter AB equals to 8. And therefore, the radius of this big semicircle must be equal to half of the diameter. So the radius R must be equal to the diameter AB over 2. AB is 8, so 8 over 2, 8 over 2 is 4. So the radius R of this big semicircle is equal to 4 units. R equals to 4. We define the center of this big semicircle. This point is point O. We define the center of this small semicircle. This point is point S. AO is the radius of this big semicircle. Is equals to 4. So what is the length of this line segment MO? MO equals to AO minus AM. Again, MO equals to AO minus AM. So, now MO equals to AO minus AM. It again, the short line segment MO is equal to AO minus AM. So MO equals to AO is the radius of this big semicircle, equals to 4. Minus AM, AM equals to 3. So in total, MO equals to 4 minus 3, that is 1. MO equals to 1 unit in its length. This is line segment MO. This is equal to 1 unit in its length. In the next step, we will do a construction. That is to say, from the center of this small semicircle, that we are looking for the area of this small semicircle. So, from the center of this small semicircle, that is to say, from point S, we draw perpendicular on chord MN. Again, from point S, that is the center of this small semicircle, we draw perpendicular to chord MN. So actually, this angle equals to 90 degrees. and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular for point S and side AB. This point is point T. So, from the center of this small semicircle, we draw perpendicular on chord MN. Therefore, we can implement here rule 15. So, a quick figure on rule 15. According to rule 15, if a perpendicular from the center of the circle to any chord so, a perpendicular from the center of the circle towards any chord bisect the chord. The line, we have a circle. Point S is the point of the circle. From point S, we do perpendicular ST on chord MN. Again, from point S, we do perpendicular ST on chord MN. According to this rule 15, perpendicular MT bisects chord MN. If ST bisects chord MN, it means that the first half MT must be equal to the second half TN, and each half must be equal to, of course, Mn over 2. So Mt equals to Tn equals to Mn over 2. We can actually implement rule 15 in our drawing. In our drawing, from the center of this small circle, that is to say from point S, we do perpendicular or ST on chord Mn. According to rule 15, perpendicular ST bisects chord Mn. That is to say, the first half N and T, or Tn, must be equal to the second half Tm, and each half must be equal to Mn over 2. So, according to rule 15, the first half Mt must be equal to the second half, that is Tn, and each half must be equal to Mn over 2. And again, according to rule 15, the perpendicular ST to chord Mn bisects chord ST. So, the first half Mt must be equal to the second half Tn, and each half must be equal to Mn over 2. Mn is 3, therefore Mn over 2 is 3 over 2. 3 over 2 is 1.5. So in conclusion, we found out that Mt equals to Tn equals to 1.5. So actually, this is the second half Tn equals to 1.5. This is the first half Mt, it must be also equal to 1.5 units in its length. So Mt equals to 1.5 and Tm also equals to 1.5 units in its length. We define this line 7 ST of the perpendicular ST SH. It is the relation for height. So ST equals to 8 units in its length according to our definition. In the next step, we do another construction. That is to say, from the center of this big semicircle, that is point O, we will join points O and S together by straight line. Okay, we join points O and S together by straight line. Again, point O is the center of this big semicircle. So from the center of this big semicircle, that is to say from point O, we draw line segment OS on called PQ. Again, we draw line segment OS on called PQ. Because of the fact that point S is the center of this small semicircle, SP must be the radius of this small semicircle. So we define the radius of this small semicircle as x. So SP equals to x. Likewise, SQ is also the radius of this small semicircle. So it equals to x according to our definition. So from point O, that is the center of this big semicircle, we draw chord bisector. OS is chord bisector. OS bisect chord QP. Again, from the center of this big semicircle, we draw line segment OS that bisects chord PQ. So here we can implement all 30. Repeat speaking on all 30. According to all 30, a line segment that is drawn from the center of a circle, line segment that is drawn from the center of the circle and bisects a chord will be also perpendicular to that chord. So here we have a circle, point O is the center of the circle, line segment OM bisect chord AB. Again, line segment OM that is drawn from the center of the circle bisects chord AB. So according to this, all 30 line segment OM must be also perpendicular to AB. Again, OM is perpendicular to OM is perpendicular to AB. According to this rule, all 30. So now you draw from the center of the circle line segment that bisects the chord. The line segment will be also perpendicular to that chord. We can implement all 30 in our drawing. In our drawing, from the center of this big semicircle, that is to say from point O, we draw line segment OS that bisects chord PQ. PQ has been bisected by OS because PS equals to SQ. The first half of PQ is PS and it is equal to the second half of PQ, that is also X. And because of the fact that from the center of this big semicircle, that is to say from point O, we draw chord bisector on chord PQ, and bisect the chord. Chord bisector OS will be also perpendicular to PQ. OS must be also, because of the fact that OS bisects chord PQ, OS must be also perpendicular to PQ. If OS is perpendicular to PQ, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 30. So, in the next step, we implement the Pythagoras theorem on this small right triangle STO. On this small right triangle STO, according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. We define the length of side SO is Y. What is the length of this line segment OT? On the drawing, it is very easy to see that OT in total equals to ON, or OT in total equals to MT minus MO. Again, OT equals to MT minus MO. So, okay, now the short line segment OT in total is equal to MT minus MO. Okay, again, this is the short line segment OT. is equals to mt minus OM. MT is 1.5 minus MO is 1. So in total, we should find out that the short line segment OT equals to 1.5 minus 1, that is 1 half. OT equals to 1 half units in its length. This is the short line segment OT is equals to 1 half units in its length. So in the next step, we will implement the Pythagoras theorem on this small right triangle STO. On this small right triangle STO, according to the Pythagoras theorem, here by PT is the version for Pythagoras theorem. So in this right triangle STO, according to the Pythagoras theorem, we have SO squared, that is the square of the hypotenuse, is equal to ST squared plus OT squared. And again, in the small right triangle STO, according to the Pythagoras theorem, SO squared, that is the square of the hypotenuse, equals to ST squared plus OT squared. And again, SO squared, that is the square of the hypotenuse, equals to ST squared plus OT squared. SO is y, therefore SO squared is y squared. And it is equals to ST squared. ST is h. Therefore ST squared is h squared plus OT squared. OT is 1 half, therefore OT squared is 1 half squared, that is 1/4. So in total, according to equation 1, we found out that y squared equals to h squared plus 1/4. In the next step, we will join points S and N together by a straight line. Point S is the center of this small semicircle. Point N is the point of the small semicircle itself. Therefore Sn is the radius of this small semicircle. It equals to x according to our definition. So in the next step, we will implement the Pythagoras theorem on this right triangle STN. Okay. So in the right triangle STN, this is the right triangle STN. So here by PT is the relation for Pythagoras theorem. So in this right triangle STN, according to the Pythagoras theorem, Sn squared, that is the square of the hypotenuse, is equal to ST squared plus Tn square. And again, according to the Pythagoras theorem, on this right angle Stn, the following equation is 2. That Sn squared, that is the square of the hypotenuse, equals to St square plus Tn square. Sn is x, therefore Sn square is x square. And it is equals to St square. St is h, therefore St square is h square plus Tn square. Tn is 3 over 2. Therefore Tn square is 3 over 2 squared, that is 9 quarters. The total, according to equation 2, from order 3, that x square equals to h square plus 9 quarters. This is according to equation 2. But according to equation 1, we only found out that y square equals to h square plus 1 quarter. So, the next step is subtract equation 2 from equation 1. That is to say, x square minus y square. So, this is equation 2 minus equation 1. X square minus x square minus y square equals to, this side of the equation we have h square plus 9 quarters minus y square, and y square is h square plus 1 quarter. So total, if we found out that x square minus y square equals to h square plus 9 quarters minus h square plus 1 quarter. We open the brackets here and get that according to equation 3, x square minus y square equals to h square plus 9 quarters. Here we have, after open the brackets, what do we have here? Minus h square minus 1 quarter. So h square minus x square is 0. 9 quarters minus 1 quarter is 8 quarters. 8 quarters is 2. So total, according to equation 3, I have found out that x square minus y square equals to 2. Okay, according to equation 3, I have found out that x square minus y square equals to 2. X square minus y square equals to 2 according to equation 3. In the next step, we will join points O and P together by straight line. Point O is the center of the big semicircle. Point P is the point of the semicircle itself. Therefore, OP is the radius of this big semicircle. We only found out that the radius of this big semicircle equals to 4. So OP equals to 4. So in the next step, we implement the Pythagoras theorem on this right triangle OSP. The right triangle OSP, according to the Pythagoras theorem, OP squared, that is the square of the hypotenuse, equals to OS square plus SP square. And again, according to the Pythagoras theorem, on this right line OSP, OP squared, that is the square of the hypotenuse, equals to OS squared plus SP squared. OP is 4, therefore OP squared is 4 squared, that is 16. And it is equals to OS squared. OS is x, therefore OS is y, therefore OS squared is y squared, plus SP squared. SP is x, therefore SP squared is x squared. So in total, according to equation 4, we should find out that x squared plus y squared equals to 16. So according to equation 4, x squared plus y squared equals to 16. According to equation 3, we already found out that x squared minus y squared equals to 2. We have two equations, 4 and 3. We relate equation 4 to equation 3 and get that in equation 5 that says that x squared plus x squared is 2x squared. We have y squared minus y squared is 0, and it is equals to 16 plus 2 is 18. So in total, we should find out that 2x squared equals to 18. Here we divide this equation by 2 and finally get that according to equation 5, x squared equals to 8 over 2 is 9, so x squared equals to 9. Our task is to find out the area of this small semicircle. So the shaded area, that is the area of the small semicircle, in total will be equal to pi x squared over 2, because of the fact that the radius of this small semicircle is x, therefore the area must be equal to pi x squared over 2. Pi x squared over 2. So it is pi over 2 times x squared. Just like the found out that x squared equals to 9. So it is in total 9 pi over 2, that is 9 over 2 is 4.5 pi. In total, we should find out that the area of this small semicircle, that is the value of this shaded area, is equal to either 4.5 pi, square units in size, or in terms of numbers, is equal to 14.137 square units in its size. And again, we should find out that the area that we're looking for in this question, that is the area of this, the shaded area, or the area of this small semicircle, that is the shaded area, is equal to either 4.5 pi square units in its size, or in terms of numbers, it is equal to 14.137 square units in its size. So in the next step, I'll start the lecture. So, our task in this question was to find out the value of this shaded area. What is the shaded area? The shaded area is the area of the small semicircle. So we have to find out the area of this small semicircle. So in the drawing we have those two semicircles. We know that this is the big semicircle. We know that line 7 AM equals to 4 units in itself. Line 7 MN also equals to 4 units in itself. This is line 7 NB is equals to 2 units in itself. Again, our task is to find out the size of this shaded area, actually the area of this small semicircle. So to find out the area of this small semicircle. First of all, because of the fact that AB in total equals to AM plus MN plus NB, AM is 3, MN is also 3, and NB is 2. So in total, AB must be equal to 3 plus 2, that is 8. So the diameter of the big semicircle is 8. So the diameter of the big semicircle AB equals to 8. Therefore, the radius must be equal to half of it. The radius R of this semicircle must be equal to the diameter AB over 2. That is to say, it is 8 over 2, that is 4. So we found out that the radius of this big semicircle, the radius R equals to 4 units. So the radius AO is 4, AM is 3. Therefore, MO must be equal to AO minus AM. Again, MO equals to AO minus AM. Again, this is the missing line 7 OM must be equal to AO minus AM. And OM must be equal to AO minus AM. So OM equals to AO, that is the radius of this semicircle, equals to 4, minus AM, that is 3. So in total, OM equals to 4 minus 3, that is 1. So the length of this short line segment MO is 1 unit. So we define the center of this small semicircle, this point is point S. We define the center of this big semicircle, this point is point O. In the next step, we implemented all 15 number 1, we did the construction. That is to say, from point S, that is the center of this semicircle, we go perpendicular to chord MN. Again, from point S, that is the center of this small semicircle, we go perpendicular MT on chord MN. Again, we go perpendicular ST on chord MN. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point S and MN. This point is point T. So from the center of this circle, we go perpendicular ST on chord MN. And whenever from the center of the circle you go perpendicular towards any chord, it will bisect the chord. That is to say, perpendicular ST bisects chord MN. According to all 15. I'm finishing on all 15. According to all 15, a perpendicular from the center of the circle towards any chord bisects the chord. So in the one, we have a circle. This is called MN, and from point S, that is the center of this circle, we go perpendicular ST on chord MN. Again, from point S, we go perpendicular ST on chord MN. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. And according to this all 15, the perpendicular ST bisects chord MN. Again, the perpendicular ST bisects chord MN. So ST bisects chord MN. The first half is MT, the second half is TN, and each half must be also equal to MN over 2 because MN is being bisected. So MT equals to TN equals to MN over 2. So if I can implement all 15 in our drawing. Why for the our drawing? From the center of this small semicircle, this is to say from point S, we go perpendicular ST on chord MN. According to all 15, perpendicular ST bisect chord MN. So the first half is MT, and is of course equals to the second half TN. Each half must be equal to MN over 2 because MN is being bisected. So MT equals to TN equals to MN over 2. According to all 15, perpendicular ST bisect chord MN. The first half MT must be equal to the second half TN. Each half, of course, must be equal to MN over 2 because MN is being bisected. But because of the fact that MN is 3, therefore MN over 2 is 3 over 2, this is 1.5. From this equation, we have that MT equals to Tn equals to 1.5. Okay. This is the first half MT equals to 1.5. This is equal to the second half Tn is also equals to 1.5 according to rule 15. Okay. What is the length of this short line segment OT? OT equals to MT minus MO. OT equals to MT minus MO. Again, MT minus MO equals to OT. And again, the short line segment OT equals to MT minus OM. MT is 1.5. This is the MT is 1.5 and OM is 1. MT is 1.5, OM is 1. So in total, the short line segment OT must be equal to 1.5 minus 1, that is 1 half. So OT equals to 1 half units in its length. OT equals to 1 half units in its length. So, in the next step, we did another construction. That is to say, from point O, that is the center of this big semicircle, we join points O and S together by side line. Again, the next step, we join points O and S together by side line. Again, point O is the center of this big semicircle. What is point S? Point S is the midpoint of PQ. Again, point S is the midpoint of PQ. That is to say, at point S, line segment PQ has been bisected. Because PS equals to X, it is the radius of this small semicircle. Likewise, SQ is also the radius of this semicircle. It is equals to X according to our definition. So from the center of this big semicircle, that is to say from point O, we go line segment OS that bisects chord BQ. Again, from the center of this big semicircle, that is to say from point O, we go line segment OS on chord PQ. Line segment OS bisects chord PQ. Why line segment OS bisects chord PQ? Because of the fact that at point S, PQ is been bisected into two halves. The first half is PS, that equals to X, and the second half is SQ, that also equals to X. So point S, line segment PQ or chord PQ has been bisected into two halves. So from the center of this semicircle, that is to say from the big semicircle, that is to say from this point O, we draw chord bisector. Chord bisector, because line segment OS bisects chord PQ. According to rule 30, whenever you draw from the center of the circle, any chord, any line segment that bisects any chord, the chord also will be perpendicular to that line segment. And again, according to rule 30, a line segment that is drawn from the center of the circle and bisects a chord will be also perpendicular to that chord. The drawing in a circle, this is point O, this is the center of the circle. From point O, we draw line segment OM that bisects chord AB. Again, from point O, we draw line segment OM that bisects chord AB. That is to say, AM equals to MB according to our construction. And because of the fact that OM bisect AB, OM will be also perpendicular to AB. OM is perpendicular to AB. This is to say this angle cos 90 degrees and this angle also cos 90 degrees according to this rule, rule 30. We can actually implement rule 30 in our drawing. Now because in our drawing, from the center of this big semicircle, that is to say from point O, we draw line segment OS that bisect angle P. Line segment OS bisect chord PQ. Again, line segment OS bisect chord PQ. Why? Because PS equals to SU. And because of the fact that line segment OS, that is one from the center of this semicircle, bisect chord PQ, line segment OS must be also perpendicular to PQ. If OS is perpendicular to PQ, it means that this angle cos 90 degrees and this angle also cos 90 degrees according to rule 30. Okay. So in the next step, we join points. First of all, we implemented Pythagoras theorem on this small right triangle STO. This small right triangle STO, according to the Pythagoras theorem, SO squared, that is the square of the hypotenuse, equals to ST squared plus TO squared. Small right triangle STO, according to the Pythagoras theorem, SO squared, that is the square of the hypotenuse, equals to ST squared plus OT squared. SO is Y, therefore SO squared is Y squared, and it is equals to ST squared. ST is H, therefore ST is H squared, plus OT squared. OT is 1/2, therefore OT squared is 1/2 squared, that is 1/4. So then we found out that Y squared equals to H squared plus 1/4. Y squared equals to H squared plus 1/4. In the next step, we join points S and N together by straight line. By joining points S and N, we created the right triangle STN. This is the right triangle STN that we created by joining points S and N together by straight line. So in the next step, we implemented the Pythagoras theorem on this right triangle SON. This is the right triangle SON. In this right triangle SON, N squared, that is the square of the hypotenuse, equals to ST squared plus TN squared. This is the right triangle STN. This right triangle STN, according to the Pythagoras theorem, SN squared, that is the square of the hypotenuse, equals to ST squared plus TN squared. Again, according to the Pythagoras theorem, in the right triangle STN, SN squared, that is the square of the hypotenuse, equals to ST squared plus TN squared. Point S is the point of this, in the center of this small semicircle. Point N is the point of the semicircle itself. Therefore, Sn is the radius of this semicircle, small semicircle, that is equals to x according to our definition. So Sn is x, therefore Sn squared is x squared, and it is equals to St squared. St is h, therefore St squared is h squared. Plus Tn squared. Tn is 3/2, therefore Tn squared is 3/2 squared, that is 9/4. So in total, we should find out that according to equation 2, x squared equals to h squared plus 9/4. This is according to equation 2, and according to equation 1, we only found out that y squared equals to h squared plus 1/4. So in the next step, we subtracted equation 2 from equation 1. Subtracted equation 1 from equation 2. Okay? It is 2 minus 1. So it is x squared minus y squared in this side of the equation. In the other side of the equation, we have h squared plus 9/4 minus equation 1, that is h squared plus 1/4. So now, according to equation 3, we found out that x squared minus y squared equals to h squared plus 9/4 minus h squared plus 1/4. Here we open the brackets of this expression and finally found out that according to equation 3, x squared plus y squared equals to x, here we have h squared plus 9/4. After we open the brackets, here we have minus h squared minus 1/4. H squared minus h squared is 0, and 9/4 minus 1/4 is 8/4, that is 2. So we found out that x squared minus y squared equals to 2 according to equation 3. Again, according to equation 3, we found out that x squared minus y squared equals to 2. In the next step, we join points on P together by straight line. Again, we join points on P together by straight line and we implemented the Pythagoras theorem. So point O is the center of this big semicircle. Point P is the point of the big semicircle itself. Therefore, OP is the radius of the big semicircle. Is equals to 4 according to what we have already found out. So in the next step, we implemented the Pythagoras theorem on this right triangle SPO. On this right triangle SPO, OP squared, that is the square of the hypotenuse, equals to OS squared plus SP squared. SPO according to the Pythagoras theorem, OP squared, that is the square of the hypotenuse, equals to SO squared plus SP squared. OP is 4, therefore OP squared is 4 squared, that is 16, and it equals to SP squared. SP is x, therefore SP squared is x squared, plus OS squared. OS is y, therefore OS squared is y squared. So in total we found out that 16 equals to x squared plus y squared. 16 equals to x squared plus y squared. This is according to equation 4, while according x squared plus y squared equals to 16. But according to equation 3, we found out that x squared plus y squared equals to 2. In the next step, we added equation 4 to equation 3. So x squared plus x squared is 2x squared, y squared minus y squared is 0, 16 plus 2 is 18. So in total, according to equation 5, we have found out that 2x squared equals to 18. Here we divided the equation 5 by 2 and found out that x squared equals to 18 over 2 is 9. X squared equals to 9. Our test is to find out this shaded area. The shaded area, what is the shaded area? The shaded area is the area of this small semicircle. So therefore the shaded area equals to the area of the small semicircle. What is the area of this small semicircle? It is equals to pi x squared over 2. Because of the fact that the radius of this small semicircle is x, therefore the area of this semicircle must be equal to pi x squared over 2. So the area of the small semicircle equals to pi x squared over 2. We only found out that x squared equals to 9, so we started x squared by 9 and found out that the value of the shaded area equals to 9 pi over 2, that is 4.5 pi square units in size. After some numbers, the value of this shaded area is equal to 14.137 square units in size. Okay, thank you very much.